Recently, our research paper introduced an attack that could potentially break down the whole internet. In today's episode of Threat Talks The Deep Dive, we dive deep into BGP Vortex, the attack that could potentially break down the internet. Let's get on to it.
Welcome to Threat Talks. Let's delve deep into the dynamic world of cybersecurity.
With me today is Eric from AMS-IX, network engineer there. Welcome, Eric.
Yeah, thank you, Rob.
And my name is Rob Maas, field CTO at Ontoit. Before we dive deep into this whole attack, can you briefly explain what AMS-IX is?
AMS-IX is then short for Amsterdam Internet Exchange. So we are a internet exchange, and what internet exchange is a platform for internet service provider who providing content services on the internet to interconnect. It's different than the internet service provider, right? Because we're working mostly with let's just say B2B with internet company, and the primary function is for people to interconnect and exchange traffic to each other. You just think about your router at home, right? So your router at home, if you have your router at home, you can connect things like laptop, PC or so through that router and then exchange the traffic locally. We are that, but on a much bigger scale.
Okay.
Yeah, it's simply you can put like that because imagine if one company in the Netherlands, right, want to exchange to internet traffic with another company in Netherlands, then they can directly connect. But then if you have many companies in the Netherlands want to exchange traffic, and then if you build that kind of like direct connection between those companies, then you have sort of a massive connection. It is not really convenient, and sometimes it's very expensive to set it up.
You're
right?
more or less the central hub that we can use to quickly connect.
That's
to
correct.
others.
So basically, with if you connect to AMS-IX with one single connection, you are able to exchange traffic to many members on the platform.
Okay.
Yeah.
Maybe also already a nice bridge because the next thing, of course, we dive into here in BGP.
Yeah.
Can you explain what BGP is?
BGP is short for Border Gateway Protocol. It's the primary protocol for internet service provider and who run network to exchange what they call the network layer reachability and NLRI between the network. So the internet, I mean, for a lot of people say that, okay, you pick up your phone and then you get on the internet, right? But then what you have access is the media, the content on the internet. And what underneath is the whole infrastructure for the internet to run, right? So from the perspective of a network engineer, we see the internet is a network of network, and all the network interconnect to each other.
Yeah, so if to make it maybe even more clear, let's assume we are both an internet provider.
Yeah.
Then we support a lot of networks, each on our own. And BGP is there if I want to tell you what networks I have behind me, and you can tell me your networks.
That's correct. So that what BGP exchange in the basics is what we call the IP address prefixes. So and then now we should understand the concept of outermost system number. So for every service provider or who run the infrastructure on the internet to provide services, then normally they have their own autonomous system number, right? And that is being assigned by the regional internet registry. Like here in Amsterdam, we're hosting the European and Middle Eastern one. RIPE NCC, it's in Amsterdam.
And that means that every autonomous system is unique in its number?
Yeah. It's it's similar to the KVK number here. Okay. You know, if you want to run a company, official business, not anything shady, then you need to register with the Chamber of Commerce for KVK number. Yep. It's just like that for the autonomous system, right? So you are being assigned a unique number, and it can only be used by your network because it's being registered internationally with the Internet Registry.
Yeah, so if I go back to the example I just described, that we are both an ISP, then we probably have registered a unique number.
Yes.
And if we know each other's number, we can send each other's updates.
The number is just like the AS number is just to identify the network, and within the network underneath is then they also need to register their IP prefixes.
Yeah.
So
that's what we will be exchanging.
Yeah, that is correct. So how say it? So let's say, for instance, it's like postcode, right?
Mm-hmm.
Amsterdam supposed to have a different postcode range compared to
so the zip code
to Utrecht, yes.
Yeah.
And then after that, you have like a specific address for your house aside to that.
Yeah. So what we will be exchanging in that example is we need to know each other numbers to know. Okay, I'm communicating with this AS number. But then I will send
and prefix IP prefix.
And
so that combination that will identify the destination, so you can send the traffic to.
Okay.
Because at the end of the day, you need to know how to send the packets from one point to another point, right?
Okay.
So that to make the internet work.
Yeah. Okay. So BGP is there to exchange all this information and make sure all these networks can eventually talk to each other. Let's move on then to the BGP Vortex. So that's what the research paper was about.
Yes.
Can you explain a bit how that works?
So I look like read the paper like from in full, right? But then look at the presentation that the researcher did. What the Vortex does is it's used the one of the feature from the BGP updates in order to trigger a condition when the upstream provider just they register the route and then they take it away. Right, so it's just like a oscillation. Yeah. So for instance, okay, let's imagine if you use navigation, the Google Maps. Yeah, to get to your destination, right? And then because of roadblock, it's update you another route. But then suddenly it just updates you another route continuously. Like that, then you cannot constant update, something like that. Then there must be something wrong with system. It's somewhat similar. It's not exactly the same, but you just create a condition from the downstream to the upstream. And now I also need to go back a little bit about how the commercial actually relation in the internet is. So for the network, because for instance, one network in Netherlands, right? Want to talk a network in the US or in Hong Kong or elsewhere in the world. I mean, what they can do is, obviously, they can run a direct connection from Netherlands to the US, but that's never happened. It's unlikely because international, say, connectivity markets, it's very expensive, right? So that network from Netherlands have to rely on what we call the transit provider, right? And then the transit provider say, okay, I will advertise your prefix from your network, and it will carry that traffic over to the global internet, right? So basically, the network from Netherlands, in the example, is the downstream for the upstream provider.
Yeah.
So, like say for instance, I don't know what internet provider you were using.
I'm using Freedom.
Oh, good. Yeah. So Freedom is it's an internet service provider here. Oh, I have friends there as well. So they have to rely on their transit provider, a bigger network.
Yeah.
Let's say Deutsche Telekom, for instance, or KPN or so, and to carry the traffic from the customer to the international market.
Yeah.
Right. So basically, let's go back to the BGP Vortex. Is what happened is in that scenario, is one downstream customer. They connect to 3 upstream ASs.
Yep.
And then from their BGP router, they send update. And that update contains 2 things, from what I understand from the paper, is what they call the BGP communities.
Okay.
And what is BGP community? It's just like something that you attach to the BGP update to tell the upstream customer, okay, this is how I want how I want you to treat my prefixes.
It's kind of a setting, hey, this is the priority you give to my prefixes?
Yeah, so yes, something like that. So for instance, if you send a packages by PostNL or DHL, you can have option to put, hey, I want to put a priority tag on my packet, right?
Mm-hmm.
It is something similar. So you have to tell to the upstream with the BGP communities to see how they treat your prefixes.
Okay.
Yeah. So so there are 2 communities that the researcher inserted in there. One is to lower what they call the local preferences. So they just tell to the upstreams like, okay, don't prioritize my prefixes.
Mm-hmm.
Yeah, that's
Lower
one
the
thing.
rest.
Yeah. So your router should not use my like the route from toward me.
Mm-hmm.
Yeah. And the second thing is like no export community. So no export community, and then they tell the upstream, don't export my community to your peers. Simple as that. And then, I mean, people who probably shouldn't put the link to the presentation from there so people can get it. I don't want to explain too much in that. But then basically they send the update with those 2 community to the 3 upstream provider and create a confusing situation.
Yeah, it's going to update itself.
Yeah.
Okay, getting in that
so
loop.
basically the upstream one say, okay, I received this route, then I don't export it to the upstream 2, and upstream 2 does not export to upstream 3. But then again, because of all the update, it just, let's say, confuse the routers from the upstream provider and creating the sort of an endless loop of BGP update.
And that will amplify because
It's
it gets
just
the
amplify,
updates.
yes.
And then in the end, it will fall down or break down because the resources are
Yeah, because
depleted.
basically BGP is an application that is really CPU intensive.
Okay, and
Yeah.
if I'm an attacker and I want to pull this off, so I want to send this update to an upstream provider, and I want to include these BGP communities, for example.
Yeah.
What do I need to pull this off? Do I need to have access directly, or can I pull this off externally?
I mean, if you get let's say if they want to induce it, then let's say if a bad actor get a hold of a legitimate downstream client.
Okay, you already need to be on a client.
Yeah, so if they have access to the BGP router from the client, they can configure this kind of update into in the downstream client BGP routers, right? But then here's the where it's I personally don't think this would be would break down the whole neither, because one of the other condition is the upstream provider have to honor those community, right? And probably in the realistic scenario, it's not. It's
normally not configured to accept the incoming changes on the BGP community.
Because for the upstream provider, they cannot really, let's say, by default accept those community. They have to have a policy to, let's say, inspect it in order to or accept it or not. So talk to Staros, one of my coworkers, said that even sometimes the lower local preference community, which is a well-known community, and some of the vendor, they just say, by default, I don't accept that.
Okay,
Because
so
it could create some unwanted consequences. So you need to, from the upstream provider perspective, you need to switch that on.
Okay,
So,
and that was nicely bridged to the next question I had is, how can we prevent against this? So disabling some of the communities might help. Are there other things that we might be able to do to prevent this malicious updates from being received and being processed?
Yeah, that, I mean, because the downstream client, let's say, if they get they can become malicious, and then they want to trigger that kind of condition, right? So but then they need to send the prefix to upstream, and the upstream have all the mechanism, all the tool in order to inspect and see that, okay, whether this is acceptable or not. So it's not by default. Yeah, it's. I mean, if the upstream don't do that, if the transit provider don't do that, then it could create a lot more problem. So it's like by accepting like those kind of community by default, it's like you're leaving your router at home, but the password of your router at home in the default password.
Yeah, is it fair to say that that maybe problems that we had in the past with BGP that already led to an optimization of the configuration, that
that's
most
correct.
of these routers are also already quite protected against this attack?
Yeah, I mean, the BGP protocol and the BGP protocol deployment within the internet is it has been for at least 30 years already. So operator has all kinds of lesson learned and all kind of mechanism in order to prevent this from happening. And one of the effect of the amplification is it could break down the BGP router CPU, right? It could overload it. But right now, if you're talking about the core of the internet, of the backbone, then those hardware are really powerful. It can handle this kind of update amplification easily.
Yeah, so it's not likely to happen with, at least not with these modern routers.
Yes, that's correct.
Okay, yeah, and that's also fair that you say, because BGP has a history of being quite resource intensive on CPUs.
Yes.
I also want to bring forward here that in the research, they only tested this with limited hardware and I believe with a virtual router to test the exchange and if they could trigger this vortex.
But yes, that's correct. That's correct. Yeah.
Okay. So, but in the unlikely event that I am at a downstream client and I want to send this malicious update to trigger this vortex upstream, if I'm successful at that, will it then cripple the whole internet, or will it be localized to this upstream?
No, I think it would be somewhat limited. It would be localized. Also, you have to because when the vortex happening, what they describe in paper is like it's just purely theoretical, right? And then in practice, there's the upstream provider. They definitely they monitor the network, and if they see these kind of things happening, then they can shut down the session immediately.
Yeah, just the BGP sessions.
Yeah,
okay.
Yeah, because I mean, we at AMS-IX we don't we not interfere with the direct BGP peering between our members.
That's just between members, of course.
But then sometimes we also, our network operation also receive question of, hey, why do I receive this many BGP update from this peer? And we say that you need to contact them to see what is going on. We are not managing them.
Yeah, that might be good to put it into perspective what AMS-IX is doing and what their members are doing. So AMS-IX is more the network connectivity, so layer 2 connectivity.
Yeah, that's correct.
And then the members, they can exchange BGP information, and they need to make sure they are protected on the configuration level, that they won't cause this vortex.
Let's say it's like this. The analogy is AMS-IX is like, okay, we're just like a conference room provider, right? So we provide conference room, we rent out conference room so people can come there and then do the talk. We don't interfere with what they're talking. You just provide the rooms and where to people to meet.
Okay,
that's something that
Okay, that makes sense and puts everything, I think, really in perspective. I think that's already brings us to the end of this recording. So BGP is the BGP Vortex is in theory possible, but because most of the upstream providers are already having such all kinds of measures in place to prevent not only this attack but also others, it's highly impractical. Given the existing controls.
And so in conclusion, they have a mechanism to control it. They have talking about network operator, right? They have experiences dealing with this because, and the whole global internet is a very dynamic environment, right? So if you're talking about prefix update, BGP update happening in the global internet, it happens daily. Like sometimes like you have outages and then somebody pull like hundreds of or thousands of prefix. It need to be propagated to the internet. So massive BGP update is nothing new for the network operator, and then they have experiences to deal with that. They do have the monitoring system to deal with that, and now more and more they have automation to deal with that.
Okay, so if they even see already something that might look like the BGP Vortex initiating, then they already cut it off, or they simply drop it, or whatever they do with it. But at least they prevent themselves.
Exactly.
Okay. That brings us to an end of this episode. So thank you, Eric. And thank you to our listeners. I hope that you like what you saw. So please click like and subscribe. And I hope to see you next time. Thank you.
Thank you for listening to Threat Talks, a podcast by Onto It Cybersecurity and AMS-IX. Did you like what you heard? Do you want to learn more? Follow Threat Talks to stay up to date on the topic of cybersecurity.